diverse populations, when we say diversity, what do we mean by that, right? Oftentimes we think diverse in our society, and even in a lot of our research, it's black and white. And that's about the extent of our diversity. Are those things important? Absolutely. And I actually, in many ways, some of the research that we do highlights that those two big things are like the two endpoints, if you will, that shapes our political environment, the access to care that we have, policy, and all of those factors as well. And that's a whole other discussion that we'll save for another time. But the core element, the core point behind that is that if we all think about diversity broader than that, it actually allows us to start thinking about our patients more broadly as well. It allows us to think about our research and the outcomes more broadly as well. So when we look at diversity, we're talking about, and some of the partners that we engage with, of course, African American churches. We partner with our rural communities, some of our rural schools even, in terms of addressing prevention and screening areas. We also work with a lot of our faith organizations. So we have a strong partnership that's building and growing now with the Islamic Association of Raleigh, for example. We also have some work that we do with the Catholic churches. And then we also have partnerships with our local FQHCs, which are our free clinics, if you will, or sliding scale clinics. And so when we think about all of those areas and the disparities that we need to address, particularly around lung cancer, is that in the United States, we have about 19 million cancer survivors. And yet, when we think about how many are actually on clinical trials, the numbers are really dismal. Anywhere between 2 to 5%, depending on the study, actually says this has how many people that are on clinical trials who could potentially be on a clinical trial as a cancer survivor. Between that 2 to 5%, even less than that are actually people who are coming from a very diverse, broader perspective. And so even as the Institute of Medicine highlighted in a report not too long ago, they said our research and our data and our participants in research are just too white. And it's too white and it's too middle class, and it's not reflecting the outcomes that we need to have. So if we look at it as treatment or work that we're doing, if we have people who we're looking at for clinical trial who's engaged in that, and they are predominantly white and middle class, then that means that we don't really have a good, clear sense of what impact this particular drug that we're testing has on every other population as well. And that's an equity issue. So does that mean that we need to take out all the white and middle class people and replace them with others? No, thank you. Someone say no. Yeah. Please say no. I'm like, please say no. Whew, gosh, because that would be a whole nother case. I'll have to take a little bit more time and have more conversation on that. But no, that's not the case at all, because I really do believe that when you have a Crayola box, I know this may seem pretty rudimentary, but you have a Crayola box, there's a white crayon in there as well as all the other colors as well. And so all need to be part of the solution, and all need to be involved in the work that we're trying to do to improve outcomes for everyone. So as a part of my partnership with Lung Cancer Initiative, I can talk about all the different work that we've been doing, but I'll talk about two in particular that I'm really excited and proud of. The first one, actually, I'll talk about Project Place, because I think some of you may have even heard some of the work that we've been doing with Project Place. We have an amazing advisory council, a community advisory council of about 20 plus people that are on this committee. It represents patients, caregivers, organizations. Jenny Denai is on it, Ron's on it as well. And it's amazing because this advisory council really gives us input, guidance, direction in the work that we're doing. Not just check off the list, but really give us hardcore information, so much so that some of the work that's come from this advisory council has actually shaped national policy around decision-making tools for the CDC, and for the American Cancer Society. So again, all of these different works that we're doing, engaging our advisory council, has been critical in making a difference along those lines. As a result of that, we received a grant called Project Place, Population Level Approaches to Cancer Elimination. The Lung Cancer Initiative, you guys had an amazing summit, and in your work, you actually allowed us to come and do part of the surveys here. As a result of that, some of the questions we have specifically asked about people's awareness around lung cancer, their awareness around lung cancer screening. Do they even know if they should be getting screened for lung cancer? And if they were diagnosed with cancer, we asked them other questions specific to that, those issues related to survivorship, and then even their diagnosis and family history. What's great about this is that our goal was to get 2,000 surveys, which we thought was a bit way over the top. We should have probably gone for like 500 or 1,000 maybe. But in fact, by the time we were done with the 2,000 surveys, we ended up getting 2,315 surveys, which was amazing, from a very diverse group of people in the Greater Triangle and across the state of North Carolina. With these data and this information, we now can partner and sit together and talk about what does that mean for the programs that we need to provide toward educating people in the community around lung cancer? What are the things we need to start thinking about in terms of screening and interventions and programs, and where do we need to be to ensure that we're reaching people who are at highest risk for this information and need that information? So we're excited about that and the next steps that come there. We've also been able to partner with the Lung Cancer Initiative on a number of other things. One is we have 2 signature programs that we partner with and one that we lead. One is our Men's Health Initiative, and the other one is our Women's Health Awareness Day. Men's Health Initiative happens every year in September. We usually screen anywhere from 250 to 400 men on any given year, and they get access to all kinds of types of screenings. And one of the opportunities we have is to be able to do the lung cancer assessment that comes from LCI. So all those men go through their assessment to be able to assess their risk. If anyone is at any type of risk or higher risk, we actually have navigators who are in the office that actually then help those men navigate them to the screenings that they need. If they don't have insurance, we navigate them to get the insurance and a medical home as well, so that we're not just focusing on their cancer diagnosis, but we're kind of focusing on them as a whole person and ensuring we can address those issues. So that's another great opportunity that we've been able to do. Likewise, Women's Health Awareness Day just happened a few days ago, actually last Saturday, and we actually, at that time, we usually get 200-300 women or so that come through, and again, we do the screening that we get from LCI, go through the assessment, and we navigate those women who need more care. So again, through our partnership and through the access grants that we receive through the Lung Cancer Initiative, we're actually making a difference and moving people through the continuum. Just over 4 years, we actually have reached over 10,000 people. In the midst of reaching our 10,000 people, we had 1,708 that actually needed some kind of screening and follow-up. Out of that, 242 needed follow-up care. So again, this is what we have been able to do through this partnership here, along with our many other partners and collaborators that we've been able to accomplish. The second thing that I am very, very thrilled about is a program where, and it's specifically around the diversity in clinical trials and research. I developed a program actually many years ago, and I've adapted it now to clinical trials and clinical research. And particularly because many of the work that we do as our office and many nationally, interventions to be able to improve diversity in clinical trials usually focuses on the patient. We need to go out to the hardest to reach communities. We need to raise education in the communities, et cetera. And those things are important. And so we spent many years doing that, and we continue to do that within the DCI, the Duke Cancer Institute. However, another thing really stood out to me, and that was that we're doing all this patient and community effort, but what are we doing in our system to make sure that when people come into our cancer centers, that they get the information that they need to be able to know whether or not they can participate in a clinical trial? And why is it that nationally we have such a lack of diversity, particularly among African American, Latinos, and Asian Pacific Islanders and Native Americans are hardly represented in any of these studies, regardless of what cancer you talk about, right? So what is it that we need to do on the system side? And so I developed this program called Just Ask. Because what we do know from the literature is that the primary reason why most people participate in clinical trials is because they were asked. We also know that the number one reason why most people don't is because they didn't even know about it. They weren't made aware, nobody informed them, no one told them. So I thought, why come up with some brilliant snazzy name? Why not just call it Just Ask? And that was pretty easy. And it actually catches on quite well as well. So we named the program Just Ask, and through this whole process now and through this training, we are actually training our clinical research teams, our physicians and our physicians and scientists in this space, and we're actually creating an opportunity where they both recognize how their implicit bias, which we all have implicit bias, so we all think it's a bad thing. It's what you do with it that makes it a bad thing or a good thing. It's not the fact that we actually have it, because all of us, if you think about in the United States, the most segregated hour in the United States is, can anyone guess?
Church.
Yep, Sundays between the hours of 8 and 2 p.m. we are more segregated than we are integrated in this country, right? And that's because that's the time when most people are in their place of worship. And so without question then, our biases are going to play out in terms of who we're around. And there's a whole bunch of workshops we could do around that.
Which helps us within race. That might sound like a nice model, except that it turns out to be completely untrue. Studies such as the Human Genome Project showed to a much more nuanced view of race genetically, where there's tremendous heterogeneity within, yes, human populations do cluster somewhat in much the ways that common sense suggests, but that within these clusters, there is large genetic heterogeneity, and that the differences between these clusters are actually relatively small. Well, how does this play into lung cancer? So probably the first racial difference in lung cancer came with a drug named gefitinib. Gefitinib was the first EGFR tyrosine kinase inhibitor, and at the time of its early development, not a lot was known about it, or at least not to the extent we do today. What we knew early on was that patients with certain clinical characteristics were far more likely to respond to this drug. Patients were far more likely to be Asian than other races. They were more likely to be women. They were almost exclusively non-squamous histology, mostly adenocarcinoma, and they were more often women. And patients with these characteristics tended to be more likely to have these dramatic responses. This is the chest x-ray of a stage 4 non-small cell lung cancer patient at baseline, and this is after only 5 days of this targeted therapy, right? And of course that patient felt a whole lot better. As we've explored a little already today, this story has played out repeatedly in non-squamous histology. We now have other molecular changes that are actionable. We have EML4 ALK, ROS1, RET, NTRK, HER2, RET, and I'm sure I'm listing off a few, missing a few already even with that list. And we're seeing other racial disparities, or differences perhaps I should say, in some of these markers, in particular EML4 ALK, which is more common in Asian populations as well. So how did this play out clinically? That's right, I can't use the fancy advanced. Gosh, at least I have a laser pointer. Academics and cats love them roughly equally. So here we have a progression-free survival from a really famous trial in my world called IPASS. What IPASS did was it randomized patients to the standard chemotherapy, carboplatin and paclitaxel, which was so for many, many years, or the new drug, gefitinib. And what happens on a PFS curve is that everyone begins the curve without progression or death, and then over time, unfortunately, people die and their cancer grows, and every time one of those events happen, the curve ticks downward. If you have to have cancer and you're being studied in such a trial, you want to be on the curve on top. That means better things are happening. This is a shape that is very famous for clinical trialists, which is to say that one agent, in this case chemotherapy, is doing better right until about the median point, and then you have crossover, and the other agent is doing better. There are multiple explanations for why this can happen, but the overwhelming majority of the time, it means that you're treating two populations, one that does better with one agent and one that does better with the other. Well, by a modern ethos, we've subdivided those populations. And what we see here is that for patients without mutation, the targeted therapy is near worthless. I'll tell you that's what older placebo-controlled curves looked like back when our drugs were so ineffective that placebo control was ethical, and this is what you expect chemotherapy to look like. But we get the aha moment when we look just at the patients with EGFR mutation, which we now know to be the driver of efficacy, where this once-a-day, less toxic pill is best in chemotherapy. Right? And I'll point out, this is what, I'll ask you to keep in mind, we're going to come back to the idea of biomarkers later, this is what a good biomarker looks like. If it's positive, you should get drug. If it's negative, you should get something else. So we are talking about genetics here, or genes, right? But we're not talking for the most part about genes that you get from your parents or can pass down to your children. We're talking about the genes within a cell, a once healthy cell in the lung. Cancer is a disease of mutations, okay? And these mutations make the cell forget how to do its normal job and instead learn how to spread and grow, the nature of cancer. And there are typically many mutations to go all the way from healthy cell to problem lung cancer cell. But one of the early events in some non-small cell lung cancers is a mutation in EGFR. So normally EGFR sits, this is the membrane of a lung cell, and normally it sits there and it only sends a signal to the nucleus through the signaling cascade to grow if it gets a signal from the body to do so. And it typically doesn't get that signal. However, in the case of EGFR mutated lung cancer, what goes wrong is in this area called the kinase signaling domain. It's sending that signal even in the absence of a signal from the body. And what drugs like gefitinib or erlotinib, osimertinib, et cetera do is they cut off that signaling, right? And this is in a nutshell, is the theme of targeted therapy. But genetics play into lung cancer in other ways as well. No, not those genes. I don't have the fashion sense for that. These mutations can also make the cancer cell look foreign. It can make it look different. And that's represented by these little purple spots here, things that look different on the cancer cell. The body has this thing called the immune system that we normally think of as fighting infections, but actually it's supposed to fight anything foreign in the body. So the immune system has these cells called T cells, and you could think of them like the xenophobes of the immune system. They float around and attack and kill anything that is foreign, and each one has a particular target, only one little thing that it can attack. So your body has these libraries of T cells, and if you're exposed to, I don't know, maybe the measles virus and you've been vaccinated, your body has an expanded population. Sorry, I wasn't supposed to touch politics. I can't help myself. You guys took out my Trump joke slide last time, but I can't help myself. Even when talking about race, I should know better. But at any rate, each T cell, right, you have this library of T cells, each of which can attack a particular thing, and if all works well, T cell sees cancer cell, it expands into an army, they kill cancer cell. And so fundamentally, if a patient has a clinically manifest cancer, there's an immune failure somewhere. There's some component of that has broken down. And of course, the immune system can be a helpful ally for attacking cancer. So what if we could harness these T cells to attack what we want them to? That's the fundamental concept behind a very, very new class of therapeutics called cellular therapeutics that I spend a lot of my time on. The most famous example of this is called CAR-T, or chimeric antigen receptor T therapy. And that's what I want to start telling you about. So the way CAR-T works is you take a bunch of T cells out of the patient's body, and then you genetically engineer a virus so that instead of causing disease, when it infects cells, it's going to change the T cells to attack what you want them to attack, in this case, cancer. So they integrate themselves into the cell, they hijack some of the DNA, and they make it express these things called T cell receptors that are how T cells attack whatever they're supposed to attack. And unlike, in the case of CAR-T, without brakes, with nothing to stop them. You take these modified T cells, you throw what's called a cytokine bath on them to make them expand, and you give them back to the cancer patient, where you hope that they hone in on the cancer and kill it. There are now 2 FDA-approved therapeutics that do this. They're for CD19 expressing lymphomas. There are classes of lymphomas that where nearly all of them express this particular antigen, and that's a critical component for CAR-T success, is that you need a preserved target that's going to be there all or most of the time for you to attack. We talked about healthcare economics a little bit earlier. Those